Well, thank you all very much for coming and for making it from breakfast. I know some of you have traveled an extremely long way and are probably still pretty tired, pretty jet lagged. So thanks for getting up at a sensible time and coming to the first session. Before I hand over to the first speaker for the event, I'm just going to give a few quick introductory remarks, try and set the scene a little bit, try and tell you a little bit about what cooperative AI is and what we're trying to achieve here at the summer school, and then giving a very brief overview of what is coming up over the next few days. Okay, so let me begin by asking this question, which hopefully you all have some idea of why you're here. But I think I want to take this opportunity to zoom out a little bit more and think about why cooperative AI, why are we working on this stuff, why are we thinking about these things. And I'll do this by referring back to actually last year's summer school. So last year we had the first ever summer school that we hosted in London. These are some of the participants. You might even see a small amount of overlap between this year and last year as well. And this year is more or less going to be the same as that, but just bigger and better. And hopefully this trend will continue. But it the fact that this happened 12 months ago or something does make one think about the progress of AI and what we've seen in the last 12 months. So even since that event, last summer, we've seen increasing AI capabilities, which I'm sure is a surprise to absolutely no one in this room, such as new multimodal models and so on. We've seen increased government interest. So you might have heard about the new AI safety institutes that are being spun up in a number of countries now, most notably the UK. And of course, the California bill, SB 1047, which again, maybe if you've had a little bit of an eye on the news, or some of you are some of you are into maybe governance or policy stuff, you will have noticed this kicking up quite a fuss, or if you're on Twitter. You'll have also no doubt heard about and seen increasing breadth of deployment. Really, these AI systems are really starting to permeate all aspects of our lives right now. Potentially one notable recent announcement being, of course, Apple partnering with OpenAI on a bunch of stuff. And I think it's also important to remember that we've seen increased corporate power consolidation. So again, no doubt you all heard about the OpenAI board coup or failed board coup. I don't think it's too extreme to call it that. But also a little bit further back, the consolidation of Google Brain and DeepMind into the new Google DeepMind. And so I think what this shows us really is that things are heating up in a way that's not necessarily good. So that was looking backwards. And now looking a little bit forwards, I want to try and draw your attention to the idea that we're going to be very soon entering a bit of a new world when it comes to the ways that AI systems are deployed and used in the real world. And this is a world of new intelligent agents. So today's standard multi-agent systems and so on, the sorts of things that you hear about, the sorts of things that you might see papers written about in conferences and so on, they are studying settings like this, right? So this is a robot warehouse where you have a bunch of different robots running around doing little things like picking up parcels and so on. But this is a well-structured environment. These agents are not really learning or adapting online necessarily. They don't have necessarily particularly competing goals. They're more or less on the same side. There's almost like a centralized planning sort of thing going on, often, not always, but often. And so essentially settings with multiple AI systems that actually interact with each other properly, adapt to one another, and in general, some situations are currently pretty rare. And this is going to change very soon. So a few reasons for why that's the case. So first of all, progress and publicity more generally is going to drive adoption by a range of actors. These actors are going to have different objectives. They're going to deploy AI systems on their behalf. Those AI systems, to the extent that they're aligned with those principles, will have different objectives. Autonomous and adaptive systems are very naturally going to outcompete those systems that are non-autonomous or non-adaptive for relatively obvious reasons. And greater and wider adoption and more modalities, the greater number of channels through which these systems can interact, is going to lead to more interactions between these systems. So what this really paints a picture of then is this new world filled with tons of agents running around doing things on people's behalf and so on. And in fact, this is not really speculation. This is the explicit corporate strategy of organizations like OpenAI. So I've taken this clip here from the announced, I don't know where it was, maybe like 18 months ago, the GPTs store, where you can have your own personalized GPT to do things like help you with your writing or your tech or your laundry or stickers or whatever it might be that you're interested in. And soon these AI systems and AI agents will be helping us with things much more consequential than that. So what? So why does that change anything? What difference does that make? Well, in the small number of settings where we do already see autonomous, powerful, adaptive agents acting in general sum environments in high-stakes situations, bad mistakes can happen. Things can go wrong, right? So maybe some of you recognize this graph, and in fact, anyone who's seen me give presentations before will know that this is an example that I like to use a lot. Does anyone want to throw up a hand? It's morning, so get the brain cells working. Who knows what this graph represents?
Flash crash.
Boom, the flash crash. Excellent. So for those of you who haven't heard of the flash crash, this is particularly one that happened in 2010. Number of high-frequency trading algorithms got locked into some weird kind of feedback loop where they wiped about $1 trillion off the stock market in about 25 minutes before it somewhat kind of miraculously bounced back. But this was an extremely big deal at the time. In fact, one of our speakers, Noam Brown, who you'll hear from later in the summer school, I later heard from that he was working at the Federal Reserve while this was happening. And the picture he paints is one of kind of, absolute kind of like terror and mortification as everyone is standing there watching these graphs kind of like plummet off a cliff with absolutely like no idea what's going wrong and no idea about how to stop it until eventually they just slam on the brakes and like prevent all trades from happening. And that was the thing that made it kind of eventually come back. So quite crazy. Other high stakes situations where, quintessentially agents do not have the same objectives as one another are military situations. So you might have seen this rather dystopian example. This is Palantir's AI War Planner, which is a large language model powered military strategic decision-making assistant that will give you hints on how to do things, like neutralize the enemy and like take out various assets and so on, such as this tank here. Very horrible. But it's also not necessarily all doom and gloom. There are many potential advantages that we might see from a world that is increasingly mediated by cooperatively sophisticated AI agents. And that might be in more kind of parochial settings like this. So we have kind of autonomous vehicles and kind of networks of kind of other kind of whatever they might be, put AI in charge of vehicles, put them in charge of all sorts of bits of infrastructure and so on. And that could really kind of, that could help in big way. And we can think bigger and bolder than that as well. So we can reason about how AI systems might generally help us cooperate. So this is a figure taken from a paper by Mikhail Bakker and some of his collaborators at Google DeepMind, which is using large language models to find consensus among humans with diverse sets of preferences and values. And you can imagine such systems being used in all sorts of things, from daily life all the way up to maybe kind of, international trade agreements and climate change negotiations and all sorts of things. So the scope is really pretty big, and the effects could be really quite large in both directions. Okay, so that's like, why are we here more generally? Why are we organizing this summer school? Why does the Cooperative AI Foundation exist? Why are you here? Well, again, hopefully you have some answer to this question already. But the thing I want to kind of, my main thing that I want to kind of get across to you and communicate and encourage you to do and to be, is to be intentional and to be focused over the workshop, over the summer school. So this event is more or less yours to make as much or as little of as you want, and we want to facilitate you to make as much of it as we possibly can. But it's helpful for you to be thinking in that mindset too. So ask yourself quite seriously, what do you actually want to get out of the next few days? Do you want to find new collaborators for a project? Do you want to learn about a specific topic? In which case, who are you going to learn about that from? Seek them out. Are you looking to get feedback on one of your ideas? Do you want to tell other people about an interesting direction? This, as much as you're here to kind of like learn and gain from other people, you yourselves are also more than capable of kind of contributing, sharing sorts of interesting ideas, interesting directions, bits of knowledge with each other. And I very much encourage you to do so. And I'm actually going to take this very seriously. I'm going to force you to sit here in silence for 2 minutes and answer these questions. So what specifically do you want from the summer school? And I mean really concretely here as well, not just like, oh, I want to chat to people, I want to meet new people, so I'm going to just walk up and, have coffee and these sorts of things. Try and be really specific. Try and think about this very carefully. Hopefully some of you have done this already. And then think about also kind of concretely how you're going to get it. Are you going to talk to this person, talk to that person? Are you going to make sure you write this idea up so you have something to share with people? What are you actually going to do about it? So that's what we're going to do. I've got a timer here. I'm going to ring the bell at the end of the timer. Whoops. There we go. I'm really serious about this. I'm going to be watching people. You got to get something to write down. I don't mind if it's a phone, it could be pen and paper, laptop, but let's go. Think about it. Write it down. Maybe you want to think a minute for what specifically you want to do, a minute for then how you're going to go and get about doing it, and I will ring the bell when we're at the 2-minute mark. I'll let you do that in peace. You're going to hear that bell a lot over the course of the next few days, so I'll get used to it. Right, hopefully you've all managed to write something down. If you've not finished, continue writing it up later or as I'm talking. I do want to stress that this is like, I go to lots of workshops and events these days, and this is like the biggest, if you want to get more out of it, like thinking about this stuff in advance is genuinely like the single biggest like cheap hack to actually doing that. It's very easy to turn up these sorts of events and just kind of drift through, and there's nice people to talk to. And then you get to the end and you're like, well, maybe I should have asked that, maybe I should have this. There's a lot of potential here. There's a lot of fantastic people around. There's a lot of amazing conversations you could be having. And it's good to think about and prioritize those in advance. Okay, thank you for bearing with me with that little kind of exercise. I do think it's useful. Okay, just before I give you a very, very quick outline of the program, I want to zoom out once more just to answer this question, which again, I'm hoping you really all have some idea of already. So what I really want to do is just leave you with just a few kind of framing ideas and a few kind of like thoughts that I find useful when thinking about cooperative AI stuff, and that might be useful when it comes to interpreting or asking questions about some of the lectures or talking to other people and so on. Okay, so what is cooperative AI? First, let me ask kind of where is cooperative AI? So in general, there's this project, you might call it, of making AI go well. And like very crudely, we might divide this into technical work and non-technical work. That's an increasingly fuzzy distinction. And I'm in fact strongly in favor of it being a fuzzy distinction. I think some of the best work actually happens in this intersection. But within technical work, there's stuff on alignment, interpretability, robustness, and then there's the cooperative AI and many other things. And in non-technical work, there's policy stuff, there's institutions that we might build, and so on. And so this is where cooperative AI lives in this overall space, that we often end up looking at and solving problems that are kind of more common within this non-technical workspace to do with kind of corporations and the building of institutions, thinking about norms, all of that sort of stuff. So cooperative AI then, as I like to define it, is a subfield of AI that studies cooperation problems involving humans, machines, or organizations, where by organizations I just mean groups of humans and machines. And its aim is both to help reduce risks resulting from AI cooperation problems, but as well as increase gains from AI-mediated cooperation, as I tried to allude to in my opening slides. And it therefore kind of forms a natural complement to technical work on kind of single-agent safety, as well as work in AI governance, AI ethics, and all sorts of other kind of efforts to improve kind of humans' cooperative abilities and our collective decision-making, our collective wisdom, you might call it. So this then kind of immediately introduces the question of, well, why are cooperation problems in the context of AI any different from regular cooperation problems that are well studied in many other places? And there's two things. So first of all, that cooperation can be harder because AI agents don't possess some features that allow biological creatures to cooperate. But secondly, cooperation can also be easier because AI agents can have or can be constructed to have non-biological features that allow for better cooperation. There are all sorts of differences between AIs and humans, and this can impact the extent to which they are able or willing to cooperate. And these features introduce a range of challenges and opportunities for us within the field. Okay, that's the first thing. Next thing I want to do is I want to briefly talk about the difference between cooperation and alignment. So some of you, I'm sure kind of most of you in the room have heard of the idea of AI alignment. You're all kind of relatively familiar with this notion. This is a very simple kind of pictorial representation. So AI alignment basically looks like the following, or at least intent, what's called intent alignment. You have a principal, a little human here, you have an agent, you have a robot. And what you just want to do, you don't care about the robot that much, you just want them to do what the human wants them to do, where preferences or values or whatever they might be, objectives here, are represented by colors. So alignment is the process here that takes a robot and gives it the same kind of preferences or values or objectives, or makes it try to do the thing that the human wants it to do. Cooperation problems almost have kind of a different type signature in some ways. So a cooperation problem instead takes a collection of agents, be they human, be they machine, whatever, who already have their preferences, and it doesn't attempt to change those preferences or manipulate those preferences or anything like that. There's no normative kind of hierarchy here where we care more about one agent than another agent, as in the previous instance. And what we instead want to do is we want to achieve good outcomes by the lights of those agents, indicated here by these happy, smiling faces. And again, just kind of continuing this analogy from my very kind of crude and simple cartoon, you can kind of actually see that kind of composing these two things actually leads us to the outcomes that we want overall. And in fact, you can kind of show this in a formal setting if you cash this out in exactly the right way. Come talk to me about that if you're curious. Second, and I believe final thing I want to leave you about on cooperative AI is the difference between cooperative capabilities and cooperative dispositions. So some of you might have heard of this idea of an orthogonality thesis proposed by Nick Bostrom, where the idea is that goals, the goals an agent has and their capabilities are somewhat independent of one another. So I can have a certain level of capabilities, a certain set of goals, and I can kind of mix and match relatively freely with those. And the same is true for cooperation. So I might really want to cooperate, but I might just be incapable of doing so. Similarly, I might be perfectly capable of cooperating, but I just might not choose to or might not want to. And so, in a sense, you get this kind of breakdown along these kind of two axes here, where this is kind of a multi-principle, multi-agent setting where some humans delegate to some robots, the robots interact and so on, and things can go more or less bad for the principle, more or less well for the principles. So you have this arrow here, which is kind of like the classic AI control problem, and again, you can think about the differences in preferences, indicated by this kind of alignment. And you can also think about differences in capabilities, in fact, the individual capabilities of the individual robots here. But at the same time, you can also draw exactly the same distinction at the kind of horizontal level, right? So cooperation, you can think about the degree of collective alignment. And essentially what collective alignment does is it measures the extent to which agents are on the same team or not. So are we playing a team game where everyone has exactly the same objectives and preferences and so on? Are we playing a zero-sum game where we're kind of totally opposed? These are kind of two ends of the same spectrum. And similarly, we can think about cooperative capabilities as well. So although it's easier to cooperate if we're all exactly on the same team, being exactly on the same team is not sufficient for cooperation. A simple example of this, of course, is, imagine kind of Nisarg and I are kind of trying to walk down a corridor and, for some reason, we can't talk to each other. I'm not really sure what's happening in this thought experiment. But for some reason, we can't talk to each other. We can't necessarily communicate. We're blindfolded. We've just got to walk down this corridor towards one another. And, I'm going to go left and Nisarg's going to go right, and that's great. We don't bump into each other. Or, I'm going to go right, Nisarg's going to go left. It's all going to be fine. But if we both go left or we both go right, then we're going to crash into each other. That'll be bad news. And so even though we have exactly the same kind of objectives, kind of we get good payoffs in the same settings, without the ability to communicate or some other kind of cooperative capability like that, then we might end up kind of reaching bad outcomes. If we're not careful, we might bump into each other. Okay. And that's a kind of silly example, but this is a theme that kind of will come up again and again. And of course, really, the world is much more complicated than that picture. It's also much more complicated than this picture. You have all sorts of principles, you have all sorts of agents, you have cooperation problems, delegation problems happening all over the place, all the time. And then I'm going to hand over to Nisarg.